What's up guys, welcome back to my channel GCSE Paradox. Today I'm trying to do something different. I'm going to use PickerWheel to help me select a random math paper, a random pure mathematics 3 paper, and I'm going to solve it. So guys, without further ado, let's begin. Uh, wait, so we have got 970, 931, ON 19. Winter paper from 2019. So guys, let's start solving. Very well then, looks like we'll have to do this one for now. So yeah, October, November 2019. So given that ln 1 plus y is to x plus y in terms of x, okay, very well. So oh, we can raise to e on both sides. You know, e raised to ln of x is always equal to x, so we are just using this rule. So 1 plus e raised to 2y equals e raised to x, e raised to 2y equals e raised to x minus 1. uh, ln e raised to 2y equals ln e raised to x minus 1. You know, taking ln of both sides, so 2y equals ln e raised to x minus 1 and y equals 1 half ln e raised to x minus 1. So I hope you guys understood this. It's just a simple rule that we used. Well, two rules actually. So this is the first one, and the second one is that ln ln of e raised to x of any number is equal to x. So moving on to the next question. Solve the inequality. Yeah, so first let's just consider this as equal to and solve. So 2x minus 3 is equal to 4x plus 1, so 2x minus 3 equals 4x plus 4, 2x equals negative 7, x is equal to negative 7 by 2, and the other one where we take the negative of one side because both are in mod. So 2x minus 3 equals to negative 4 x plus 1, 2x minus 3 equals minus 4x minus 4, 6x equals to minus 1, x equals minus 1 by 6. Now you can just so like these are the values, mostly like endpoints, and if you substitute these values as if you substitute these values for x, you'll get both sides equal to 0. But let's just confirm that, because there are these values are absolute values. So just to confirm that these are the endpoints, we can just substitute. So let me just check. So when x equals negative 7 by 2, we get 10, and 10 on the LHS, which is the left hand side, and we get we also get 10 on the right hand side, which means this is one of the endpoints. And when x equals minus 1 by 6, we get 10 by 3 on LHS, the left hand side, and we get 10 upon 3 also on the right hand side, just to confirm. So these two are the endpoints, means at these points, uh, the left hand side is equal to the right hand side, but we just have to uh, find the values of x for which the left hand side is greater than the right hand side. So how about we take some random value in between? Let's say we take -2. So when x is -2, LHS is equal to 7 and RHS is equal to 4. So as you can see, when I take some value between -7/2 and -1/6, I took just I just took any random number. I took -2. As you can see, my LHS is actually greater than RHS. So that means it's pretty obvious that the range of values that will be valid to satisfy this equation with this condition would only be for values of x that are between -7/2 and -1/6. So we are just going to say that this is the range. Okay, so I hope you guys understood this. It's just that we just find the endpoints first, which are -7/2 and -1/6, and we just check for random values either before -7/2, after -1/6, or maybe in between those. So I just took a random value in between those. So if you take any random value before less than -7/2, or maybe after -1/6, you'll get LHS is maybe less than RHS. Like, it just won't satisfy the equation of LHS being greater than RHS. So moving on to the next question, parametric equations. I hope you all know one equation of parametric equations, which is dy dx equals dy dt divided by dx dt, because it's just derivative of y with respect to t and derivative of x with respect to t. So over we just have to do the same thing. First we'll find dy by dt, which is the derivative of this function with respect to t. So uh, I hope you guys know that derivative of any natural logarithm is just 1 upon x, 1 upon the number. So we get 1 upon 1 minus cos 2t. Then we'll have to take the derivative of this inside part, chain rule. So the derivative is I guess it's sine 2t multiplied by 2. So the derivative is 2 sine 2t divided by 1 minus cos 2t. So I hope you guys understood how, like, we just first take this in the denominator, so we get this part, and then we take the derivative of this part, 1 minus cos 2t, and you know that derivative of cos theta is negative sine theta. So derivative of cos 2 theta is going to be negative sine 2 theta, and so on. Derivative of cos 2 theta is going to be negative 2 sine 2 theta, because you have to multiply with 2 also, again chain rule. So well, this is dy dt, and dx dt is just going to be 2 plus, now we are going to take the derivative of this again with respect to dt or time t. 2t plus cos 2t multiplied by 2, same as over here, which is equal to 2 plus 2 cos 2t. Now to find dy by dx, we just have to do dy by dt upon dx by dt, which is 2 sine 2t divided by 1 minus cos 2t divided by 2 plus 2 cos 2t which is 2 sine 2t divided by 1 minus cos 2t, 2 plus 2 cos 2t. So, well, now we just have to solve this, and yeah, and we somehow have to get this dy dx is cosec 2t, which is 1 upon sine 2t. So let's solve this trigonometric expression. Let's see. So 2 sine 2t divided by 2 plus 2 cos 2t minus 2 cos 2t plus minus 2 cos square 2t. Yeah. So we have 2 sine 2t divided by 2 minus 2 cos square 2t. Yeah. Plus minus get cancelled, and we have 2 sine 2t divided by 2 1 minus cos square 2t, which means 2 get cancelled, so we have sine 2t divided by 1 minus cos square 2t. And I hope you guys know this, sine square t plus cos square t is equal to 1. So sine square 2t plus cos square 2t is also equal to 1. So 1 minus cos square upon 2t, the denominator will just give us sine square 2t. So now moving on, we get sine 2t divided by sine square 2t, which is 1 upon sine 2t. Hence dy by dx is equal to cosec 2t. Moving on to the next question. Now we have some differential equations. The number of infants in a population T weeks out of the start of option denoted by n. Population decreasing at a rate proportional to this. So we know that dy by dx is proportional to negative, because it's decreasing, negative n e raised to minus 0.02 t. Variables n and d are treated as continuous, and it is given that when t equals 1000, n equals 1000, when t equals 0, n equals 1000, and d and dt is negative 10. So we just have to prove this. So since it's proportional, means there has to be a constant. So dy by dx, oh, I'm so sorry, it's actually going to be dn by dt, because it's change of n with respect to time t. Sorry guys, my bad. So we have dn by dt is equal to negative k. Instead of proportional, we can just take a constant, equal to negative k e raised to minus 0.02 t n. And yeah, we have some fixed values, so we can use these. So we know that when dn upon dt is negative 10, n is 1000, and e is t is 0. So these negative get cancelled, so 10 equals 1000 k e raised to 0, which is 1000 k. So 10 equals 1000 k, k is equal to 0.01. So there we have it, dn by dt, you know, getting this formula back, dn by dt is equal to negative, we found the value of k, which is this, we have negative 0.01 n e raised to minus 0.02 t. Hence proved, guys. Now, yep, we'll have to solve the differential equation, which is going to be for 6 marks. I have to find the value of t when n equals 800. So we have dn by dt is negative 0.01 n e raised to minus 0.02 t. Let's bring all the n terms on one side. So we have 1 upon n dn is equal to minus 0.01 e raised to minus 0.02 t dt, and we can just integrate both sides. Correct. uh, let's integrate this side from 0 to n, and this side from 0 to t, which basically means we are just simply integrating without considering any, you know, values to substitute. So we had discussed this, that the derivative of any natural logarithm is going to be the number itself in denominator, which is 1 upon x in this case. So we'll just use the same thing. Integral of 1 upon n, which is antiderivative, is going to be ln of n. So this is on the left hand side. This is going to be equal to minus 0.01 constant, and we know that integral of e raised to x dx is always going to be e raised to x. So e raised to minus 0.02 t, but we have e raised to minus 0.02 t. So you'll have to divide the derivative of this part. So with respect to t, you have to divide the derivative of this part with respect to t by this. So divided by minus 0.02. This is the integration, and we'll add c, integration constant. So I'll tell you guys why we divided, why we did this part. Why did we divide this? So it's actually just simple u substitution. See, let's say you have e raised to 10x integral with respect to x. So let u equals 10x. So du is equal to, so du with respect to x is equal to 10. So du equals to 10 dx. So dx equals du upon 10. So we'll just substitute dx equals du upon 10 in this equation. So we get integration of e raised to 10 upon x du upon 10, and 10 upon x was actually u, so we can just write this as u du upon 10. So we'll have 1 upon 10 integral eu du, which is equal to 1 upon 10 e raised to u, which is equal to 1 upon 10, and u was actually 10x, so 1 upon 10 e raised to 10x. So you see, we divided the derivative of this part. So that's all we are going to be doing in this one. Just a second. Yeah. So ln of n is equal to 1 upon 2 e raised to minus 0.02 t plus c, and we have some constants, right? When t equals 0, n equals 1000. So we'll use that. When t equals 0, n equals 1000. We'll use this afterwards. So coming back to this, if we raise both sides by e, which is basically, e raised to ln of n is basically n. So n equals e raised to 1 half e raised to minus 0.02 t plus c, and you'll know this product rule, right? Like if we have e raised to x multiplied by e raised to a, this will give us e raised to x plus a, correct? So we are just going to use this. We have e raised to this term plus this term. So this is actually equal to e raised to 1 half e raised to minus 0.02t multiplied by e raised to c, and since c is a constant, e raised to c is also a constant, so we can just substitute this as c multiplied by e raised to 1 half e raised to minus 0.02 t. So there we have it, n equals c e raised to sorry e raised to 1 half e raised to minus 0.02 t. I hope you guys understood why, because we are just using the simple rule, like we have e raised to c plus uh, whatever, let's say we have t, so this is just equal to e raised to c multiplied by e raised to t, which is, and since we know that e raised to c is constant, so e raised to c is also going to be a constant, let that constant be c, so we have c e raised to t, assuming e raised to small c is equal to capital C, just another constant. There we have it, and I guess we can just substitute in the values, so n equals 1000, t equals 0, so 1000 equals, to find the value of c, so c e raised to 1 half e raised to 0, 1000 equals c e raised to half, so c equals 1000 e raised to minus half, which means n is equal to 1000 e raised to minus half multiplied by e raised to 1 half e 0.02 t. Getting these things together, 1000 e raised to 1 half e 0.02 t minus half. Alright, so again simplifying further, we have n equals 1000 e raised to we take half common, e raised to minus 0.02 t minus 1. Alright, this whole thing is raised to e. We just have to find the value of n when t equals 800. Sorry, when n equals 800. So 800 equals 1000 e raised to half e raised to minus 0.2 t minus 1, 8 upon 10 equals e raised to 1 half 0 to t minus 1. So ln 8 upon 10 equals 1 half e raised to minus 0.2 t minus 1, 2 ln 8 upon 10 equals e raised to minus 0.02 t minus 1 plus 1, and the ln of whole thing equals this, so we just take this over here, which is equal to 29.6, approximately 29.6. So final answer is t is 29.6. So we just have to simplify a lot. State what happens when value of t to the value of n as t becomes large. So t approaches infinity, and where's the equation? Yeah, here it is. N equals 1000 e raised to half minus 0.02 t minus 1. So when t approaches infinity, we have um, let's see, first first of all we have this as 1000 e raised to minus half 0.02 t plus 1, and we can kind of disregard this plus 1 because at infinity plus 1 is kind of negligible. So we have n equals 1000 e raised to minus 1 half into infinity. If you solve 0.02 into infinity, which is equal to 1000. Oh, sorry guys, I just realized I made a mistake over here. This is actually a 1 half e raised to minus 0.02 t minus 1. So n equals 1000 e raised to 1 half, and e raised to negative infinity, which is simply 1 upon e raised to infinity, which is 1 upon infinity is equal to 0. So we have this term right here, e raised to minus 0.002 t. When t approaches infinity, this term will approach 0, correct? So we have half 0 minus 1, so 1000 e raised to minus half, so n equals 1000 upon e raised to half, which is root t. Moving on, curve with equation is has stationary point when x equals p. So at stationary point dy dx 0. There's just a lot of calculus in this paper, but I just randomly selected it from that picker wheel. Show that p satisfies this equation. Okay, so dy dx is equal to, we'll use product rule. The derivative of minus 3 divided by ln x minus 1 plus e x minus 2 x multiplied by the derivative of ln x minus 1. So we have e raised to minus 2x multiplied by the derivative of minus 2x, which is minus 2 into ln x minus 1 plus e raised to minus 2x multiplied by 1 upon x minus 1 multiplied by the derivative of x minus 1, which is just 1. So I hope you guys understand why I'm multiplying this minus 2, because you have e raised to minus 2x, the derivative of this, which is equal to e raised to minus 2x, again the same thing, but that will be multiplied by the derivative of minus 2x. Chain rule, you first take the derivative of the whole thing, then you take the derivative of the thing inside, which is minus 2x, and then you multiply it by that. So minus 2 e raised to minus 2x into ln x minus 1 plus e raised to minus 2x upon x minus 1 is dy by dx. And when x equals p, dy by dx is simply 0. So we can just substitute x as p and dy dx as 0. So 0 equals minus 2 e raised to minus 2p into ln p minus 1 plus e raised to minus 2p upon p minus 1. So 2 e raised to minus 2p ln p minus 1 plus e raised to minus 2p divided by p minus 1. Sorry, this is equal to e raised to minus 2p into p minus 1. We have e raised to minus 2p to ln p minus 1 equals e raised to minus 2p and yeah, both of these get cancelled, divided by 2p minus 1. So ln p minus 1 equals 1 upon 2 into p minus 1. P minus 1 equals e raised to, which is xp, because e raised to 1 upon 2 upon p minus 1 is simply exp. So 1 p equals 1 plus p minus 1. Let me just check. Yup, it's exactly how it's supposed to be. Correct? Yeah. Now verify by calculation that p lies between 2.2 and 2.6. So uh, let's form an equation with this. So we have, we'll just take everything on one side. So 1 plus exp 1 over 2p minus 1 minus p is equal to 0, and let this be, let's say, f of x, you know. Sorry, it's going to be f of p because p is our main variable over here, and when p is equal to 2.2, f of 2.2 is equal to 1 plus, so we are just going to substitute p for 2.2, you know, p is equal to 2.2, and we'll just use our calculator to find the answer. So I just use my calculator to find the answer, and we get 2.52, and for f of 2.6 means p equals 2.2, sorry, 2.6, we get minus 0.233. Oh, and I forgot to subtract p in the calculator, so this is going to be, so this is just going to be 0.166. So see, if you guys can see, initially the value was 0.166, then it became negative 0.233. Means when the value of p goes from 2.2 to 2.6, f of s changes from 0.166, sorry, f of p changes from 0.166 to minus 0.233, means there is a value where f of p is equal to 0, because it's between positive and negative values, correct? And that value occurs when p is somewhere between 2.2 and 2.6, and in that value the difference, like we took p on this side, correct, from the first equation. P was initially over here, but we just took it on the left hand side, so the difference is 0, somewhere between 2.2 and 2.6. That means LHS is equal to RHS, so we can find the value of P. So this is just to prove that much. Now you have to find the value of P correct to 2 decimal places, and each iteration to 4 decimal places. So let's take the first value as some random value between 2.2 and 2.6, which is 2.4. So if you substitute, sorry, this is actually P1, P2. So if we take P1 as 2.4 in this equation, P n plus 1 equals 1 plus exp 1 over 2 pn minus 1. If we take P1 over here we'll get P2, and that is 2.4292, 4 decimal places. Then P3 is 2.4188, P4 is 2.4225, P5 is 2.4212. Oh, okay. So as you can see, we got correct to two decimal places, the same decimal. So to two decimal places, we are getting P as 2.42. Correct? Yeah. So let's move on to the next question. Okay, again a calculus question. My god, what's up with this calculus in this question paper? So cos x upon sin x, we just have to differentiate using a product rule. So dy by dx is equal to negative sin square x minus cos square x divided by sin square x, which is negative sin square x plus cos square x divided by sin square x. Sin square x plus cos square x is 1, so negative 1 divided by sin square x, which is negative cos x square x. Correct, that's what we had to prove. I hope you guys understood what I did here, because I just used the division rule, the quotient rule. So derivative of cos x multiplied by sin x minus the derivative of sin x multiplied by cos x divided by sin square x. This is equal to the derivative of cos x over sin x. Alright. Now again a calculus question. Okay, we have this. Maybe we can use product rule. Integral of uv is equal to so integral of uv means, let's take u as x dx and dv as cos x square. No, sorry, let's take u as x and dv as cos x square dx, because we know the integral of cos x square. So du is equal to dx in this case, and v is equal to, let's see, we know that integral of negative cos x square x is cos x upon sin x, because we just found this out in the first part. So let's see, we only have positive cos x square x, so v is going to be negative cos x upon sin x. And I hope you all know the formula. It's just uv minus the integral of v dot du to integrate this product rule. So we have x dot y, so this is going to be minus x cos x upon sin x minus the integral of minus cos x upon sin x du. Alright, so this will give us negative x cos x upon sin x plus integral of cos x upon sin x dx. Now mm, let's see, let's take sin x as u. So we know that du is equal to cos x, du over dx is equal to cos x, so dx is du over cos x. So we have integral of cos x upon sin x dx is equal to integral of cos x upon sin x du upon cos x. Cos get cancelled. We have integral of 1 upon sin x du. 1 upon sin x is basically 1 upon u. So we have integral of 1 upon u du, which is ln u. So, and u was sin x. So we have this derivative of integration of cos x upon sin x dx. This part is equal to ln sin x, and continuing upon sin x, and now we just have to apply the limits, which are pi upon 4 to pi upon 2, pi upon 4 to pi upon 2. So minus pi upon minus pi upon 2 cos pi upon 2 divided by sin pi upon 2 plus ln sin pi over 2 minus pi over 4 cos pi over 4 divided by sin pi over 4 plus ln sin pi over 4. If you solve this, uh, yeah, so if you solve this, we'll get yep, so we'll get 0 plus sin 90, sin pi upon 2 is sin 90, which is 1, so 0 plus ln 1 minus pi over 4 plus ln of 1 over root 2, and ln 1 is 0 again, so we have pi upon 4 minus ln 1 upon root 2, which is pi over 4. Let's multiply the numerator and denominator by root 2. So we have minus ln root 2 raised to minus 1, and you all know, I hope you all know the properties of logarithms. Let's say we have a raised to ln b, so this is equal to ln of b raised to a, so we can just take this minus 1 over here. We have pi over 4 plus ln root 2, and uh, see, we have to take it somehow in ln 4 terms, correct? Because the question has pi upon 4 into 1 plus ln 4. So let's say I take the square of this and divide this by half, because if you see, it's actually the same thing. Half ln root 2 the whole square is equal to ln root 2 square into 1 half. Okay, if you are going to take this here using this rule, so this gets cut, which is simply ln root 2. So I have pi upon 4 plus 1 half ln root 2 square, which is 2. Again, I'll do the same thing. I'll take square and divide this by 2. So I have pi over 4 plus 1 upon 4 ln 2 square is 4. Now we take 1 upon 4 common, we get pi plus ln 4. Yup, correct. So hence proved. I hope you guys understood what I just did here, because let's say you have ln 2. If you take the square of this and you divide this by half, it's the same thing as ln 2 in the end, because it's ln 2 raised to 2 into 1 half. You know, half can come here, property of logarithms, and this gets cut, so it's simply ln 2 again. So two lines L and M have equations, this and this, where A is a constant. It is given that the lines intersect. So there's a point where x, y, z are coordinates of both the lines are equal. Find the value of A. So let's take for R1 first. X is A plus lambda, y is 2 minus 2 lambda, z is 3 plus 3 lambda. Alright, and for R2, it's 2 plus 2 mu for x for R2. For y, it's 1 minus mu, and for z, it's 2 plus mu. Let's take I, j and k instead of x and y and z. I, j, k, I, j, k. So I told that there is one point where both the i's, the i's and j's and k's of both are equal. So a plus lambda is equals 2 plus 2 mu, 2 minus 2 lambda is equal to 1 minus mu, and 3 plus 3 lambda is equal to 2 plus mu. We can use these two equations to find the value of lambda and mu. Alright, so I guess if we just add them, we get 5 plus lambda is equal to 3. So lambda is equal to minus 2. And we can find mu using the second equation. For example, we can even use the third one. So 2 minus 2 into minus 2 equals 1 minus mu. Mu equals 1 minus 6, which is minus 5. So we have mu as minus 5 and lambda as minus 2. We can substitute both of these in this first equation where we have a. So a minus 2 in place of lambda is equal to 2 plus 2 into minus 6. A is equal to minus 8. Oh sorry, mu is actually minus 5, not minus 6. So here it's going to be 5, so we get minus 6. Then we have, when a has this value, find the equation of the plane. So I hope you guys know that plane is not actually there in the syllabus, so we'll not be doing this question. But and honestly, I have learned according to the latest syllabus, so if you still want the answer to this question, I suggest watching some other videos on this paper. let f of x equals x square plus x square plus 6 divided by x square into x square plus 2, express f of x in partial fractions. Alright, so we have x square and x plus 2. So you all need to sort of memorize this, the partial fraction format, when we have a square term and we have a monomial term. So x square plus x plus 6 upon x square into x plus 2 is equal to ax plus b divided by x square plus c upon x plus 2. So x square plus x plus 6 is equal to ax plus b multiplied by x plus 2 plus cx square. Alright guys, there's one more method for this. I guess this would be a bit tedious and long. Instead, how about we do it this way? A upon x plus 2 plus b over x plus c over x square, because anyways even if you take the first format the answer is going to be correct. It's just that we have to check if the LCM of the denominator is equal to this term. So if you check, well, if you take common terms and stuff, you get x plus 2 into x square again, so it's the same thing. So anyways you're going to get the same thing if you use ax plus b, the previous one that I just shown and just erased, or this format. I think this would be a bit easier because this would not be as long. So x square plus x plus 6 equals a into x square plus b into x plus 2 plus c x plus 2. Let's take x as 0. So you know we can, so when x is 0, 0 plus 0 plus 6 is equal to a into 0 square plus b into 0 into x plus 2 plus c into 2. So both of these terms are going to be 0. So 6 equals c into 2, c equals 3. Now let's take x as minus 2. So I hope you guys understand why I'm taking these values. These are not just random values, 0, minus 2. I'm taking minus 2 so that you know we get minus 2 plus 2 here, and value of b and c goes to 0, so that I can find the value of a. So minus 2 the whole square minus 2 plus 6 equals a into minus 2 the whole square plus b minus 2 plus 2, which is 0, plus c into minus 2 plus 2. Both of these go to 0, and we get 8 equals 4a, a is equal to 2. Now we can just take any other random value because we just have to find one variable, which is b. We have found a and c, so let's take x is equal to 1. So 1 plus 1 plus 6 is equal to a into 1 plus b into 1 into 1 plus 2 plus c into 1 plus 2. So we have 8 equals a, 2a is basically 2, so 2 plus b into 1 into 1 plus 2 is 3 plus c is 3, so 3 into 3 9. So minus 3 equals 3b, b is equal to minus 1. So there we have it. Now we just have to substitute in a, b and c in this, and we'll get the partial fraction format, which is 2 over x plus 2 minus 1 upon x square. Wait, am I doing in the correct order? No. Minus 1 upon b plus 3 over x square. So this is what we got so far. Now again a calculus question. We have to integrate the partial fractions. We basically have to integrate f of x, but f of x, this is equal to this and this is equal to this now, the partial fraction format. So we have to integrate this thing. So integral of 2 over x plus 2 minus 1 over x plus 3 over x square with respect to dx. So yeah, and this is from 1 to 4. So integral of 1 upon x plus, we'll just take this, parts by parts, plus 2 upon x plus 2, then minus 1 upon x, then 3 upon x square. Integral of 1 upon x plus 2 is just ln x plus 2. So this is going to be wait, there's a 2 over here, so 2 ln x plus 2, this is minus 1 upon x, so minus 1 upon x, the integral with respect to x is going to be minus ln x, and this is just integral of 3x raised to minus 2, this part, with respect to dx. So this is going to be 3x raised to minus 1, minus 3x raised to minus 1, correct? So yeah, and this is the limits are from 1 to 4. So this is going to be 2 ln 4 plus 2 minus ln 4 minus 3 into 4 minus 1, this minus, so I'm just erasing this because there's no space. This is going to be minus 2 ln 1 plus 2 minus ln 1 minus 3. This is 2 ln 6 minus ln 4 minus 3 upon 4 minus 2 ln 3 minus ln 1, which is 0, minus 3. Oh sorry, I forgot to take the minus sign, so minus plus plus, yeah. So we have ln 6 square, taking 2 over here, minus ln 4 minus 3 upon 4 minus ln 3 square plus 3. And there's one property of logs, like let's say you have ln a minus ln b, so this is going to be equal to ln a upon b, and if you have ln a plus ln b, this is going to be ln into ab, correct? So this is equal to ln 36 divided by 4 minus ln 9 plus 3 minus 3 upon 4, which is 9 upon 4. This is again, the 9 will go in the denominator, so ln 36 upon 4 into 9 plus 9 upon 4. I hope you guys understood why. Then we have ln 36 upon 36 plus 9 upon 4, ln 36 upon 36, which is ln 1 plus 9 upon 4, which is again equal to 0. So we have 9 by 4, the final answer. By first expanding cost, we must make sure that cost yes is for okay. So we can just use the data booklet to expand. So this is going to be cos 2x cos x minus sin 2x sin x this is equal to the expansion for cos 2x plus x. So this is 2 cos square x minus 1 multiplied by cos x minus 2 sine square x cos x, which is 2 cos cube x minus cos x minus 2. This sine square x can be written as 1 minus cos square x multiplied by cos x, which is 2 cos cube x minus cos x minus 2 plus 2 cos square x multiplied by cos x, 2 cos cube x minus cos x minus 2 cos x minus 2 cos cube x. Oh, sorry, this will be plus because I already took the minus sign over here. So this is going to give you minus 2 actually. You know, minus 2 into 1 is minus 2. So I don't happen to be an expert, I still make silly mistakes. So we have minus 2 cos x plus 2 cos cube x, which is 4 cos cube x minus 3 cos x, and this was equal to cos 2x plus x, which is cos 3x. So guys, hence proved cos 3x is similar to 4 cos cube x minus 3 cos x. I just hope there's no calculus question following. Hence solve the equation this. Okay, so cos 3x was 4 cos cube x minus 3 cos x plus 3 cos x plus 1 equals to 0. So cos cube x is equal to negative 1 by 4. Cos x is equal to cube root of negative 1 by 4. So we have to find the answer in radians. So this is 2.25, and we just have to find in this range. So in terms of degrees, this value is somewhere around 130, so it's somewhere around here. The other value is going to be over here, and since this is 180, the range is below 180, so we can only take values before 180. So hence 130 degrees, which is 2.25 radians, is the final answer. There's only one possible answer for this, because we have to see with respect to this interval. Again, a calculus question. Let's hope this is the last calculus question. So we had this 4 cos cube x minus 3 cos x is equal to cos 3x. So 4 cos cube x is equal to cos 3x plus 3 cos x. This was from the first part of this question. So cos cube x is equal to 1 upon 4 cos 3x plus 3 cos x, and we just have to simply integrate this. So integral from pi over 6 to pi over 3 of 1 upon 4 cos 3x plus 3 cos x dx, which is equal to 1 upon 4 cos 3x. Integration is simply sine 3x divided by 3 plus 3 sine x, and this is what we have been given limits for, pi upon 6 to pi over 3. So we have 1 upon 4 multiplied by 1 upon 3 sine 3 pi over 3 plus 3 sine pi over 3 minus 1 upon 3 sine 3 pi over 6 plus 3 sine pi over 6. This will give you 0 plus 3 root 3 upon 2 minus 1 over 3 plus 3, let's see, 3 upon 2. So we get 1 upon 4 into 3 root 3 upon 2 minus 11 upon 6, and if you want to just take the common denominator out, we get 1 upon 4 into 9 root 3 minus 11 over 6, which is no multiplication, 1 upon 24 into 9 root 3 minus 11. Alright guys, now yeah, so there are I guess 2 questions left. Let's continue. Complex number u is given by this. Showing all necessary working without using a calculator, find the square roots of u. So square roots of u is just going to be in some form, let's say x plus iy. So u is going to be x plus iy the whole square, because complex numbers are written in this format, x plus iy. So u is minus 3 minus 2 root 10I is equal to x square plus 2xyi plus y square I square. So minus 3 minus 2 root 10I is simply equal to x square plus 2xyi minus y square. Minus y square because I square is simply minus 1, because I is root minus 1. So I square y square is going to be minus y square. So we know that the term in I is this. So minus 2 root 10I, which is the only term in I, is equal to the only term in I on the right hand side, which is 2xyi, and x square minus y square, the constant terms, is equal to minus 3. So minus root 10 equal to xy, and x square minus y square equal 3. Y equals minus root 10 upon x, solving simultaneously. So x square minus root 10 upon x the whole square equals 3. So x square minus 10 upon x square equals 3. So solving, x raised to 4 minus 10 equals 3x square. So x raised to 4 minus 3x square minus 10 equals 0. Now we can just solve it quadratically, and we'll get x square equals to so we get x square equals to 5 or negative 2. But since we know that x square equals minus 2 means x is a root of negative number, which is not possible, correct? So x square is equal to 5 only. So x equals to root 5, and y, which is minus root 10 upon x, is minus root 10 upon root 5, which is minus root 2. So, well, I think, oh wait, I just forgot, x can be plus minus negative 5. So even this, so when x is positive root 5, y is negative root 2, and when x is negative root 5, y will have to be positive root 2. So the two roots, the two square roots are root 5 minus root 2i. Hold on guys, I think I might have just messed up a little bit. Oh, oh guys, I found a mistake, and it'll probably be the silliest mistake of all times. Well, this was negative 3 and somehow it became positive 3. Great. You know, this is actually so embarrassing. So it's going to be minus 3 plus 3. So this whole thought is going to be wrong. Let's just cancel this and move ahead. So we have x, we'll move ahead from this part. So we get x square is equal to either 2 or minus 5, but minus 5 is not possible because x cannot be a complex number in this case. So x is equal to root 2 plus minus root 2. When x equals root 2, y is equal to y, remember y was minus root 10 upon x, so y is equal to minus root 5, because minus root 10 upon root 2 is minus root 10 upon 2, which is minus root 5, and we just switch the signs. When x is minus root 2, we get y is positive root 5. So basically we have this plus minus root 2, you know, x plus iy format, root 2 minus root 5i. Alright guys, moving on. On a sketch of an argand diagram, shade the region whose points represent complex numbers z satisfying the inequalities z minus 3 minus 5 less than 3. So this one's going to be a circle, and for the circle the properties are center is going to be 3 comma 1. This is just because it's z minus x plus iy, which is z minus x minus iy. So x and y, in this case if you compare it to z minus 3 minus I, will give you x as 3 and y as 1. Yep, so this is the center, and the radius is less than equal to 3, and the another one is a half line, which means argument of z has to be greater than equal to pi upon 4, means z is greater than equal to tan inverse of pi by 4, oh sorry, it's going to be the tangent, not tan inverse, of pi by 4, which means the gradient of this half line is 1. Sorry, it has to be greater than or equal to 1, and it starts from 0 comma 0 because it's arc z. It's usually z minus x plus iy, but x and iy both are not present over. It's just arc z, so x and y both are going to be 0. And lmz is greater than or equal to 2, means the imaginary axis. So we have this z imaginary axis. This is going to be greater than 2, so we have this line 2 over here. So only the points greater than 2, correct? So let's start. We have this. So for the circle, center is 3 comma 1, radius is less than or equal to 3. So the three corners are, not the corners, the 3 points on the circle are so we just draw a circle, and its radius less than or equal to 3. So we'll take the inside of the circle, but let's just not shade at this moment. We'll first have to add in all the other parts to this question. So yeah, we'll have to add the other parts of the question to this diagram. Then we have this half line part. So it starts from 0 0, gradient is 1, so we get a line like this, and it's greater than 1, so it's going to be the part above this line. Then finally we have lm2, this line, and the part above this line. So the area that's going to be shaded is this. This is the lmz greater than or equal to 2 line. So guys, yeah, so yeah, this is the horizontal line, this is the lmz line, this is the lmz line, this is the half line, which is arc z is equal to pi by 4, and well, this is the circle. This is the final answer, region R. So finally this paper has come to an end. This was actually a great time. I mean, this was my first time solving a random paper using the PickerWheel. Well, let's end this video. It's already too long. So thanks for watching. Please like and subscribe. GCSE Paradox signing off.